Okay, today we're going to talk about how to solve lines of fit and then look at scatter plots. So first thing we're going to do is I'm just going to talk about real quick what they look like and how we know if it's positive, negative, no correlation, which is pretty simple to tell, right? So if you want to draw these down, you can. You don't have to, because I think you'll be able to tell fairly easily what they're doing. Should have done this before because when you kind of annoying when you put all these dots on there. It doesn't matter where your dots go on the page as long as they look something close to this. Okay, so we have three different types of correlations here. Can anyone tell me what they would be? Ryan?
Positive, negative, and no.
Yeah, right. The first one obviously is going up, so we know that's going to be a positive correlation. The second one we know is going to be negative. And then the last one is going to be no correlation. Okay. Now, can anyone tell me when we're talking, like, can anybody tell me something like a real life situation that would show a positive correlation?
Grades, like.
Okay. In reference to what? The more time you spend studying, right? So if X value is hours spent studying, the more time you spent studying, what happens to your grades? The better your grades are, right? What about a negative correlation?
The less time you study.
Well, but your X value still goes to more, okay?
Oh.
What keeps you from studying?
Watching TV.
Okay, so let's say this is hours spent watching TV. What happens the more hours you spend watching TV? Your test grades go down, right? Can anyone tell me something that would be no correlation?
Probably
Doing sports
studying and watching TV.
at the same time.
Well, that would still be a correlation. You would want to choose two things that have nothing to do with each other at all.
Eating.
And sleep.
So, for example, hair color, number of pets, right? Do those two things have any correlation to each other? No, right? Okay, just because you have black hair doesn't mean you have more pets than someone who has blonde hair, right? Those two things are not related. So, listen, when we talk about a correlation, right, typically we're going to look at, especially for today, we're looking at either positive correlation or negative correlation because you can't write an equation if there's not a correlation for two things, okay? So, most of the stuff we're looking at today, positive or negative, yes?
Yes.
Okay, here we go. First thing, I'm not going to go over this problem with you specifically because I think you guys are capable of doing this. It just says create a scatter plot for the data. So if it gives you the number of miles and the number of phone calls, what are you going to do with those things?
Plug them in.
Yeah, they're ordered pairs, right? What's my first ordered pair? 4, 8. Sorry, I know it's hard for you to see up there. Okay, so we know we would just plot a point up here at 4, 8. You guys can go through and take care of that. Yes? Because plotting ordered pairs is not new to us. So first thing we're looking at today, just creating a scatter plot. Easy stuff, right? Okay, the next thing, this is where it gets a little more important. I'll kind of zoom in after I read so you can see. It says the data points on the scatter plot below show the amount of time spent watching television, which we just talked about, right? And the amount of time spent doing homework. So this is for 21 students. It says draw a line of best fit for these data points. Notice it says it doesn't have to be the exact line, just draw your best approximate, okay? So what's happening the more time you spend watching television?
Hours of homework done.
Right? Listen, I had a conversation with someone about this last hour. They were asking me about their grade, and I was like, well, how much time did you spend playing video games last night? Yeah, what do you think happened? Less homework done in my class. Okay? Yes. So, here's what we're saying. On this, it's not even necessarily asking you to be concerned with that. It's just asking you to draw a line of fit. Okay, so when it talks about line of fit, there's a few different ways that can look, right? You want to draw a line that goes through the majority of your data set. So I would do something that looks like this. Now I'm going to draw it in actually in a minute, but if you drew it like this, would that still be okay?
Yeah.
Yes. If you went over here kind of like that, that would probably be okay. Would this be okay? No, because your line doesn't go through the majority of the data set. Now, the other thing I'll tell you is I've already seen some people on today's assignment do something like this. Do you think that would be a good answer? No, because it's not going through the majority. So just make sure when you draw your line of best fit, you're trying to get it as close as you can to the majority of your data set. Cool? Okay? It will be important when we start to write the equation for it. All right? Okay, question number 3. This one's fairly simple too. I'll zoom in after I read. Okay? The scatter plot shows theater revenue and rental revenue for 21 movies. Also, notice they have already drawn in a line of best fit for you. Okay? For all of these questions, they're asking you to use the line of best fit. So, question number 1 says, for these 21 movies, as theater revenue increases, rental revenue tends to do what?
Decrease. Oh,
So as theater revenue, which is your X, increases, as it goes up, what's happening to your Y value? Okay, so what do you think you're going to choose here? Increase, right? For these 21 movies, there is a positive, negative, or no correlation. Positive, right? So we know it's going up. We're going to choose a positive correlation. Okay? The last one says, using the line of best fit, so using this line, we would predict that a movie generating a theater revenue of $60 million, okay? Where is 60 million located on the x-axis? Right here, okay? The rental revenue would be approximately what? So what you should do is go up to the line, so this line of best fit, and then tell me, what is that Y value? Well, if I go straight across, it's about 11 or 12 million dollars. So when you choose your drop-down menu, you're going to choose something that's close to 11 or 12. Here's where people have made mistakes today, right? They went to 60 and they saw an X value here and picked 8. Well, is 8 on the line of best fit? No, okay? So read the question because it asks you using the line of fit, not just the data set, but the line of fit. Does everyone understand the difference? Okay? Good stuff. Moving quickly. All right. Next one. Sorry, I don't know why that's so difficult for you to see. Is that a little better?
No.
It's a little better.
I just feel like the glare is... Okay. All right. We'll just keep going. Okay, it says scatter plot shows time spent texting and the time spent exercising. So when people spend, what they're saying is, when people spend more time texting, they spend less time doing what? Exercising. Okay? Now, it says, here's where I really want you to pay attention. Use the equation of the line of best fit. I'm going to write out here so you can see it a little better. Y is equal to negative 0.74x plus 8.64. We can use this to answer all of our questions. Okay? Question number 1. What is the predicted time spent exercising for a student who doesn't spend any time texting?
Well, you're gonna plug.
Would you plug
You're
in
gonna plug X in
zero?
for 0.
Well, 0 in for x, but yes. What happens if I plug in 0 in for x to all of this?
It would just be 8.
So, again, when x is 0, that is your what?
That's your value, your Y value.
Not your y value, your y intercept, right? So every time x is 0, that's our y-intercept. So if a student spends no hours texting, what is that telling us about the time spent exercising? 8.64 hours, right? Again, I didn't even need this graph to know that because I can look at my equation. Because 0 hours spent texting, 8 hours spent exercising, okay? Question B. What is the predicted time spent exercising for a student who spends 4 hours texting? How could I figure that out?
Plug in 4.
Okay, let's do that. Y is equal to negative 0.74 times 4 plus 8.64. Okay, Obviously, since these are decimals, I will let you all use your calculator. Negative 0.74 times 4 is equal to negative 2.96. And then if I add 8.64 to that, what do you get?
5.68.
Right? Now, that should make sense to us because it said 4 hours. And if we zoom in here, what did we get as our answer? About 5.6. Well, isn't 5.6 about what's on that line of fit?
Yes.
Yeah. Okay. So that should make sense to us. Okay. Last question. This is where most people have had trouble today. It says for an increase of 1 hour in the time spent texting, what's the predicted decrease in the time spent exercising? So basically, what it's asking, for every hour that we go up here, an increase in 1 hour of the time spent texting, what's the decrease here? Where could you find that?
On the
Graph.
Where could you find that in your equation?
You plug in each.
It wants to know what's the change per hour.
Well, you plug in.
Who said that?
Slope.
Yes, Connor. Yeah. Isn't slope the change in y over the change in x? So if it's just asking for the change per hour, where can we find that in our equation?
negative 0.5.
Yeah, in front of x every time, okay? Now, you may not type in a negative because it already says predicted decrease, so it'll probably just be 0.74 because they're already telling you it's a decrease, right? So here's the easy part of this, you guys. It asks you 3 questions. It's always going to ask you if there's whatever it is, if your x value is 0. Well, anytime your x value is 0, isn't that your y-intercept? Yes. Then it's going to ask for the change per hour. That is always going to be your slope. Okay? Then the last thing, it's just going to ask for predicted for a certain amount. You plug it in and solve. Cool? Questions on any of this?
No.
Okay, last one. This is the one you need to be most careful with, okay? It gives you, it says years of experience and then pay in dollars, right? So obviously, the more years of experience you have, the more pay you're going to get, correct? Okay, so it says, part A, write an approximate equation of the line of best fit. It doesn't have to be exact. Then we're going to use our equation to find or predict the hourly pay for 18 years of experience. All right? The first thing I would do is I would draw a line of fit, so because it gives you that tool to do that. So you're going to choose 2 points and you're going to draw a line of fit here. Okay? Now, I'm going to try to make this a little smaller so you can still see it. All right? Something like that. Now, then, in order to write an equation, what 2 things do we need to write an equation in slope-intercept form? Slope and y-intercept. How am I going to have to find that from a graph? Well, it's kind of hard to do rise over run with this type of graph. But
2 minus 1.
there we go. But I can find 2 ordered pairs, correct? Okay, so what I want to do is choose 2 ordered pairs that are on my line of fit. Is anyone's answer in here going to be the same? No. And you might even have the exact same problem and put in 2 different answers, and that's okay, all right? But what we're going to look at is somebody tell me what this ordered pair would be right here if my x value is here.
310.
3, 9 would probably be okay because, again, it's approximate. Sorry, I'm going to write that over here. Okay, and then let's use this one since it's on 20. So 20 and
20 and 16.
17 because it's about, yeah, it's about midway. Did I say 20? 20 and 17. Cool? Okay, so we've written an ordered pair. I'm going to switch to the next screen so you can see it a little better. 3, 9, 20, 17. 3, 9. Okay, now, how can I use these 2 ordered pairs to write an equation? What's the first thing I should be doing?
Y2 minus Y1 over X2 minus X.
Okay, So my y2 is what? 17. Minus y2 minus y1. And then x2 is 20. It's doing that to me again. 20 minus my x1 is 3. Okay? All right, what is 17 minus 9?
8.
And 20 minus 3? Now, here's where it's different from what we've done, you guys. It doesn't give you the option to leave it as a fraction, so what should you do?
Put it in a decimal.
Yeah, change it to a decimal, right? 8 divided by 17 is going to give you 0.47. We're always going to go to the hundreds place, okay? Yes?
No rounding though?
Round to the hundreds. Yep. Every single time, you guys, I want you to round to the hundreds place, because then I don't think we'll have any problems. All right? So 0.7 is going to be my slope. I'm going to write that over here to the side, because I'm going to use that later. What other thing do I need to write an equation in slope-intercept form?
Y-intercept.
Y-intercept. Which ordered pair do you want to use?
3, 9.
That'd be a good choice. Okay? All right. Now what am I doing? 9 equals,
0.47 x.
what is my x?
3.
Plus b. Okay? So 0.47 times 3 is going to give you 1.41. Then all I have to do to solve for b is subtract 1.41 from both sides. What value do I get for b? 759. Okay? All right. Do I now have the two things I need to write my equation? Okay. What is my equation in slope-intercept form? Okay. Now, I'm not going to go over the last part because I think you can do it. I'm going to look and see what number it says. It says, predict the hourly pay for somebody that has 18 years of experience. What would you do with the number 18?
Plug it in for X.
Yeah, plug it in for X and solve. You guys are capable of doing that, so I'm going to give you time to do that instead of going over it. But how do we feel about this today? Good? Any questions? Okay, your assignment is posted on Alex. Make sure you get on there, show all your work on your paper. On the problems that are like you're just plotting ordered pairs or drawing lines of fit, just tell me it's a graph, okay?